Greetings everybody and welcome back to another exam video. Today we're taking a look at the 2016 Methods Exam 2 multiple choice. So let's jump straight into it. Question 1, we've got a linear function with a particular range and we want to find the corresponding domain. The nice thing about a linear function is that it's one-to-one. And the nice thing about a one-to-one function is to solve these sorts of questions where you're given the range, let's say. To find the domain, the endpoint of the domain should be exactly where the function equals to the endpoint of the range. So in particular, you can just take your function, 5 minus x, set it equal to -4, solve, and that gives you x equals 9. And do the same thing for the endpoints at 5, that gives you x equals 0. Now 4 was a closed endpoint, 5 was an open endpoint, which means on this domain D, 9 must be a closed endpoint and 0 must be an open endpoint. So match up the answers, it's going to be option A. Question 2, we have a trig function that I believe has been appearing on every single multiple choice section of each exam for the past few years. So asked to find the period and range of this function. How do you find the period? Well, it's going to be 2 pi divided by the coefficients in front of x, which is pi on 2, and pi's are going to cancel. This 2 in the denominator of the denominator is going to flip up to become a 2 times 2 in the numerator, and that's going to give you 4. The range, you take the mean position, which is 1, add or subtract the amplitude, which is 2, which gives you -1 or 3. So period is 4 and the range is -1 to 3, so it has to be option B. Question 3, part of the graph of f is shown below. We can assume f is a cubic. Doesn't necessarily have to be, I believe, but we'll just assume it's a cubic. Okay, so f prime of x is less than 0, 4. So we just look on this graph over here. Where is this graph? Where's the gradient of this graph negative? Well, it's on this branch over here, as well as this branch. And that's precisely -infinity up to -2. So maybe I'll draw a little picture here. -infinity to -2. Then it's also negative from 1/3 up to infinity. So let's see what the correct answer should be. So 1/3 to infinity. It looks like it's going to be option C. All the other ones, yeah, if you have closed endpoints, that's not going to be correct because this is a strict inequality. If you're at the endpoints, you have your f prime is equal to 0. Okay, the average rate of change of the function f with this particular rule between 0 and 3 is, just use the average rate of change formula, or if you have the CAS programs, go to methods differential calculus, average rate of change, and then we type in 3x squared, then -2 square root of x plus 1, comma x, and then we have from 0 to 3. That gives us 25/3, which is D. If you're interested in the CAS programs, then link will be in the description. Question 5, which one of the following is the inverse of this function? Well, it's going to be some kind of quadratic first of all. So maybe you can eliminate one or two options already. We can use the inverse program. So you go to inverse over here, and we type in the square root of 2x minus 6, and then comma x. And it gives us x squared over 2 plus 3, which you can rewrite as x squared plus 6 over 2, and x is greater than 0. Okay, looks like it's going to be option D over here. Which makes sense because, well, the range of this guy, the range of G, is going to be exactly 0 to infinity, right? Because this square root graph over here, it's starting precisely at 3. Because you solve the inside equals to 0. The start point is at 3, and you're going up to the right. So the range is 0 to infinity, so the domain of this guy, G inverse, must be 0 to infinity. Alright, question 6. Consider the graph of the function defined by, well, it's a sine of 2x. The square of the length of the line segment joining the point on the graph for which x equals pi and 4 and x equals 3.4 is. So first of all, let's try to figure out the points on the graph. With x equals pi and 4 and 3 pi and 4. So it's going to look something like, well, if we write this out, it's going to be pi and 4, comma f of pi and 4. That's the points at pi and 4, and then for 3 pi and 4, it's the same thing. F of 3 pi and 4. And we just need to find the distance between these 2 points over here. What you can do, instead of having to calculate what these 2 points are, you can just define your function f of x to be equal to the sine of 2x, and then just refer to those 2 y coordinates there as f of pi and 4 and f of 3 pi and 4. Now you just need to use the distance formula, or if you have the programs, you can go to miscellaneous, go down to linear info, and just type in, well, we wanted pi on 4 and f of pi on 4. Okay, and we also want 3 pi on 4 and f of 3 pi on 4. So do that, and that should give you a distance of, okay, square root of pi squared plus 16 on 2. We wanted the square of the length, so we're going to remove the square root and square the denominator. So that's going to be pi squared plus 16 on 4, which is a. If you don't have the programs, you just have to use the distance formula on this, but without the square root. So that's going to look something like 3 pi on 4 minus pi on 4 squared, that's the difference in x coordinates, then plus f of 3 pi on 4 minus f of pi on 4, but squared. So that should give you the answer if you just type that into the cuz. Question 7. The number of pets x owned by each student is a random variable. If 2 students are selected at random, the probability that they own the same number of pets is. Okay, so we have random selection, so we can assume independence for this. So how can we have the same number of pets? Well, if the first student has 0 pets and the second student has 0 pets, it's going to be 0.5 times 0.5. And then same for 1 pet, 0.25 times 0.25, and then plus the others as well. We can multiply the probabilities directly because everything's independent. So the choice of one student, or not the choice, the event that one student has 0 pets, let's say, won't affect the probability that another student has 0 pets. And that's the idea. So we just have to type this in over here, 0.5 times 0.5 plus 0.25 times 0.25 plus, actually I just realized I can just do squared. Why am I not doing that? And then plus 0.05 squared, 0.3126, and that's going to be 0.25, 0.2 squared, 0.05. That's not right because I did multiplication here, silly me. That should be 355, so that's going to be option C. Okay, I knew something was wrong there because that wasn't appearing in the answers at all. So let's forget about that. Let's forget about that row there. Okay, question 8. What do we have? The UV index for a summer day in Melbourne is illustrated in the graph below, where T is the number of hours after 6 AM. Okay, the graph is most likely to be the graph of. Well, first thing we can identify with this graph is the period. The period is obviously going to be 14 because you notice that it repeats, it gets back to the same position after 14 time units, or 14 hours in this case. So we know the period is 14, so let's try to find the coefficients in front of that t there. It's going to be 2 pi divided by n. We set that equal to 14 and we try to find n. So n is going to be 2 pi over 14, which is pi on 7. So we need a pi on 7 in front of that t there, so we can eliminate c, d, e. So now we are left with, well, is it 5? The mean position is 5, that is correct. Mean position is 5. The question is it a plus 5 cos or a negative 5 cos? Well, notice at the start over here, we're starting at a local minimum. So we have to have a negative 5 cos. If you had a plus 5 cos, you're starting at a local maximum and you're just following the usual cos graph. So it's going to be B. Question 9. Given that the derivative is equal to this guy, find the integral. So just integration by recognition. How to do integration by recognition? Just start off with this equation here. Integrate both sides. Integrating the left-hand side, the derivative and the integral will cancel, leaving us with x e to the k times x. Integrating the right-hand side, you're going to get the integral of kx plus 1 e to the kx dx. But now we can use the linearity of the integral to split it up across this addition. Actually, I should distribute first of all, just to make it a bit clearer. E to the kx, and then plus e to the kx dx, like so. And this is equal to k times the integral of x e to the k times x. And then we have dx, and then also plus the integral of e to the kx dx. So I just split up the integral. Now I wanted, well, what's the integral that I wanted? I wanted this integral over here. And nicely, I can see it sitting right over there. So all we have to do now is rearrange everything a little bit. And let's see what we get. What we can do first of all is subtract this integral from both sides. That leaves us with x e to the k times x minus the integral of e to the kx dx equals to k times the integral of x e to the kx, oops, x is up there, dx. Now we only want the integral of x e to the kx, so we have to divide both sides by k. That's not too tricky to do. So dividing both sides by k, we can put it over here perhaps. And let's try to match up the answers. So we have A is not going to be correct, B is not going to be correct. Or maybe it is correct, I'm not too sure. Let's keep looking. C, that's not going to be correct. D looks promising because we have a 1 over k, x e to the kx, and then minus an integral of e to the kx. That's right over here. Then we still have that 1 over k multiplied inside. So it looks like it's going to be option D. E does not look correct, I believe, because we have a k squared x e to the kx. We only want a 1 over k x e to the kx. And B wouldn't be correct either. If you just expand that out, I believe you shouldn't get the same thing. Okay, question 10. For the curve y equals x squared minus 5, the tangent of the curve will be parallel to the line connecting the positive x-intercept and the y-intercept when x is equal to. Let's draw a picture, because there's a lot going on over here. The curve x squared minus 5. What does that look like? Probably looks like that somewhat. Here's the y-intercept at negative 5. And we have x-intercepts. You can calculate this. That's negative root 5. Sorry, root 5 and negative root 5. The tangent to the curve will be parallel to the line connecting the positive x-intercept and the y-intercept. So what exactly is the line connecting those 2 points? It's right over here. We're trying to find the x-coordinates, or the x-points, where the tangent at that point matches the gradients with that line there. So why not try to find the gradients of that line connecting those 2 points? What I'll do is I'll define f of x to be equal to x squared minus 5. And what I'll do, we can find that gradient there quite easily. If you just take a look at this, rise over run. Rise is precisely 5, run is precisely root 5. So that's going to be equal to square root of 5. Okay, so we want to find where on this graph f is the gradient equal to root 5. You can just use the solve grad program on the CAS. Solve grad, and we'll do, just need to do that. And then we'd put an f of x, comma, square root of 5. And we found a point, root 5 on 2. If you don't have the programs, you'll just have to do, what was it? We have solve, and then you do the derivative with respect to x of f of x, and you set that equal to square root of 5 with respect to x. That gives you the same answer. Alright, question 11. We have a functional equation here. Which one of the following is a possible rule for the function? So, what we'll do is we'll just take a look at this expression over here, and whenever I have functional equations, by the way, functional equations are outside of the study design now, but whenever I have a functional equation, I like to move all the functions, I guess, onto one side, just so I have the right-hand side equals to 0. That way, when I type in this, or when I evaluate this functional equation, then I just need to check whether it equals to 0 or not. I don't have to check both the left and right-hand side. So to do that, I'm going to, first of all, let's define a function. Let's just take the first one to be x squared. F of x equals x squared. And what I'll do is I'll type in f of x and then minus f of y. And I'll move everything on the right-hand side over. So we're going to have minus y minus x. And then f of x times y. Make sure it's a multiplication between x and y. Otherwise, the CAS will treat x, y as one big variable. Evaluate it. You don't get 0, so it's not going to be f of x equals x squared. So you can try the next one and reevaluate the functional. That's not going to be it. Try the next one. That's going to be x times log base e of x, was it? Indeed. Reevaluate the functional. You don't get 0. Try 1 over x. 1 over x. Reevaluate the functional. And you get 0. So it looks like that's going to be the answer, D. And just to check, you can also try 1 over x squared. Reevaluate the functional. You don't get 0. So it's going to be option D. So for these sorts of questions, well, you're not going to see them anymore, I believe, but it's just trial and error. Question 12, the graph of a function f is obtained from the graph of a function g with this particular rule by a reflection in the x-axis followed by dilation from the y-axis by a factor of a half. Which one of the following is the rule for the function f? So we're going to transform g, if you read it carefully, we're transforming g to obtain a function f. Now, how is g being transformed? Well, the first thing that's happening to g is a reflection in the x-axis. A reflection in the x-axis means you, well, turn y's into negative y's. So you're just going to pick up a negative sign in front of that square root there. And then we have a dilation from the y-axis by a factor of a half. If you dilate from the y-axis by a factor of a half, you replace x with 2x. Because, well, if you dilate from the y-axis by a half, you're changing your x values. In particular, you have to replace x with 2x, so that's going to be 4x, and then minus 5. So whenever, a general rule of thumb is whenever you have transformations happening on the inside of your function, you always kind of do the reverse of the transformation, but if you have transformations happening on the outside, you just keep it the same. That's why translations, usually you have to replace x with x minus something if you have a positive translation. So it's going to be negative 4x minus 5, so it's going to be option D. Question 13, what do we have? We have what we want to find the area of the shaded region. So I guess let's just look through the options. So integral from a to d of f minus g wouldn't be it, because f minus extends down here. If you do the integral from a to d of the difference of two functions, you're trying to find the area between two curves, which also include maybe this area down here. So a is not it. B, 0 to d of f minus g. That's not going to be it either. Similar reason to the first one. Actually, the first one was a to d. So you're not even going to be picking up that area at the starts between 0 to a there. 0 to b of f minus g. So 0 to b, I'm not too sure why they do... 0 to b of f minus g. Again, that's not going to be it, because if you do the integral between the difference of two functions, that's the area between curves, which also includes this area down here, if it exists. So it's not going to be c. D, the integral from 0 to a of f of x, so looking good so far, because you're only focusing on the function f. Then you do the integral from a to c of f minus g, which looks good, because here you're doing the difference of two curves, the area between the two curves from a to c, which is what you want. Then the integral from b to d of f of x, but that's just going to give you this big area which you don't want, so it's not going to be d either. So hopefully it's c. Let's reason through it. So the integral from 0 to d of f of x. Okay, so what does that give you? It gives you this big area here, then minus the integral from a to c of g. Now if you go from a to c of g, you're only picking up that area. You take the difference. That's the area that's remaining, which is the shaded area. So we'll have to go with option E. Question 14. A rectangle is formed using part of the coordinate axes. U and V is a point on there. Y equals 4 minus x squared. Which one of the following is the maximum area of the rectangle? Okay, so what's the area of the rectangle in terms of U? The reason why I choose U, not V, is because V can be easily expressed in terms of U as just 4 minus U squared, because the point of V is lying on the graph, and this is the relationship between x and y coordinates. So it's u times 4 minus u squared. That's the area, and we just need to find the maximum area of this rectangle. So what better program to use than the analyze program? So we'll go analyze with domain, and we'll do u times 4 minus u squared. Just make sure that you put a multiplication between u and the bracket. Otherwise, if you just put it like that, the case will assume u is a function, which it's not, it's a variable. We'll do comma u, comma 0 to, I believe it was 2, right? Indeed, it was 2. And here's the local maximum, which is indeed the maximum. So 16 root 309, that's going to be option E. If you don't have the programs, you will just have to find the stationary points of this function, and then just take that point and plug it back into the function, because that gives you the area. Question 15, a box contains 6 red marbles and 4 blue marbles. The 2 marbles are drawn from the box without replacements. The probability that they are the same color is... Okay, so tree diagram, we have 6 red marbles, 6 red and 4 blue marbles. 2 marbles are drawn from the box without replacement. So each time you're picking a marble, you're changing the probability. So we'll just do a tree diagram here. We have 6 red, so we can either go red or blue. Now, after we do red, we could either have red or blue once again, but I don't care about blue. I care about it being red because we're after the same color. So we can go red or red, and then blue. Again, you have red or blue, but I don't care about the red branch. I care about the blue branch. So blue over here. So let's calculate. There's 10 marbles altogether, I believe. So we're going to have something over 10, something over 10 initially, then something over 9, something over 9 after that, because we take a marble out. So how many reds are there? There's 6. So put 6 over here, 4 down here. Now, after you take, there were initially 6 red, you've already taken 1 out, which means there's 5 remaining, so you've got to put a 5 over here. And same for the blue. If you've taken a blue on the first pick, then for the second pick, you only have 3 remaining. So let's multiply across and add 6 times 5 plus 4 times 3 divided by 10 times 9. That's going to be 30 plus 12 over 90. And that's 42 over 90. That's 21 over 45. We can simplify this, divide by 3. So 7 over 15. That's going to be option C. Okay, 5 more questions to go. Question 16. Random variable x is a normal distribution with mean 12 and standard deviation 0.25. If the random variable c has standard normal, the probability that x is greater than 12.5. So we're trying to find the probability that x is greater than 12.5 in terms of z. That just means standardize. So how do you standardize x? Well, you just take your points, you subtract the mean, which is 12, divide by standard deviation, and what do you get? It's probability that z is greater than 0.5 divided by 0.25. What's 0.5? It's a half. Divide by 0.25, which is a quarter. And that's going to be 4 divided by 2. That's 2. So z is greater than 2. Looks like it's option E. Question 17. Inside of a container, there are 1 million colored building blocks. It's known 20% of the blocks are red. So we know our P over here is 20%, 0.2. A sample of 16 boxes taken from the container. So we're working with small samples and large population. So we can assume binomial. Yeah, do not assume normal approximations. We have to assume binomial. And what we'll do for samples of 16 blocks, p hat is the random variable of the distribution. Okay, we want to find p hat is greater than or equal to 3/16. So to do that, we just need to set up the corresponding binomial random variable. We have binomial, and then we have number of trials is 16. Probability of success is 0.2. Okay, and we just need to convert this p hat over using the rule p hat is equal to x on n. So if you have something in terms of p hat, you just need to multiply everything through by n. So that's equal to the probability that x is greater than or equal to 3 on 16th times 16th, which is 3. So we just need to calculate this binomial probability now. Not too tricky to do. It's menu 55B, and then we'll do 16.2, and we're going from 3 up to 16. And that gives us 0.64. So it's going to be option A. Question 18. Continuous random variable x has a PDF given by this guy over here. The value of a such that here x minus x less than a is root 3 plus 2 and 4 is. So you just need to find, well, what exactly is this probability here in terms of an integral? Well, it's the integral. We're trying to set root 3 plus 2 on 4 equal to the integral. Now this PDF, where it's non-zero, it starts at 3 pi. So we're going to go from 3 pi. That's the start of where the distribution is non-zero. And we're going to go up to some points a here of the function f of x, dx. So if you integrate from 3 pi to a of your density, that gives you the probability from 3 pi to a, but that's the same thing as the probability that x is less than a. Okay, so we just have to evaluate this now. I'll define f of x. I guess you don't really have to define it in this case, but I'll just do it anyways. Cosine of x on 2. Okay, and what I'll do is I'll solve, what was it? It was root 3 plus 2 on 4. I'll solve this equal to the integral, so shift plus for integral, from 3 pi all the way up to a of f of x dx, and I solved this with respect to a. And I get some funny numbers because we're working with a trig graph here, so let's see, a must be between, well, it should only go up to 5 pi. Maybe let's try that, because, well, your density is 0 after 5 pi, so we'll do such that 3 pi less than x less than 5 pi, hopefully that works. That doesn't give us, it's a, not x, what am I doing? Because we're solving for a. 14 pi and 3. Option B. Okay, almost there, 2 more questions. Question 19, consider the discrete random variable with random variable x. The smallest and largest possible values of e of x are respectively. Okay, so I believe this was one of the trickiest questions on the exam. So right away what I'll do is I'll just write down a bunch of equations which I know. First of all, because we have unknowns in that probability row there, I know that we must have a plus 4b, because there's 4 b's in total, a plus 4b plus 0.2 equals to 1. That's something I know. And what we're interested in is finding the possible values of e of x. So let's maybe write down e of x, just so we know what we're trying to work with. E of x is equal to negative a, and then plus b squared, then plus 4b squared, plus 0.8. Okay, but that's equal to, so I just took the product of each column, added it together. That's b squared, that's 4b squared, that's 0.8, and that's equal to negative a plus 5b squared plus 0.8. Okay, we're working with 2 variables here. It would be nice if we have 1 variable. Nicely, we have 2 equations though, so we could sub one into the other. I'm looking at this first equation here. We could probably sub that into the second equation, because the second equation, this e of x, that's what we're really interested in. It would be nicer if we had e of x just in terms of 1 variable to play around with. So we can substitute a. That's probably the easier one to do. So a is equal to, subtracting 0.2 on both sides, we get 0.8. And I'll just do minus 4b. Okay, so plugging that in, what is e of x now? We have minus 0.8 minus 4b plus 5b squared plus 0.8. Let's clean this up a little bit. So we have a positive 4b plus 5b squared. We have a negative 0.8 and a positive 0.8, so that cancels. So e of x we can write as 4b plus 5b squared. Okay. So now we have to think about, well, what's the smallest and largest possible values of e of x? Now we have this quadratic in b. Maybe let's graph out b, or the quadratic in b rather. So let's see how we can graph this. That's equal to, if we factor b, let's say, that's going to give us 4, then plus 5b, I believe. So we're going to get an intercept at 0. b equals negative 4/5, I believe. Negative 4/5, so we have a graph that looks like this. First of all, b has to be positive. I just realized, because b is in this in these probabilities, so we need b to be positive, so we can forget about everything over here. So b has to be positive. What's the largest b can get? Well, let's take a look at this probability here. How big can we make b? Because obviously b can't be too big. For example, b can't be like 0.9 or something like that. Otherwise, the probabilities down here will add up to something greater than 1. So what's the largest b can get? Let's think about this. Well, if we want the b to kind of dominate here, we kind of want a to be as small as possible. Well, the smallest a can be 0. So what happens if a is 0? Well, we're going to get 0 plus 4b plus 0.2 equals 1. But that means 4b must be equal to 0.8. So b must be equal to 0.2, it looks like. So that's the largest b can get. If b is any bigger, then, well, the probabilities down here is going to add up more than 1, which is what we don't want. So I don't think we even need this graph here. We just need to take b between 0 and less than or equal to 0.2. And well, this graph is useful because we know our function is strictly increasing. So to find the smallest and largest possible values of e of x, we can just plug in the endpoint, which is not too tricky to do because plugging in 0 into there is 0. And we just need to plug 0.2 into this equation. So what is exactly 4 times 0.2 plus, what was it? 5 times 0.2 squared. It's exactly 1. Okay, so b is between, or the e of x is between 0 and 1. So it looks like it's going to be option E. Final question, question 20. I believe this was one of the harder ones. I don't know which one of these are harder, I'd assume. I think it was 19 that was harder. More people didn't get that right. So question 20. We have a transformation that maps f onto g. We know the integral of f is 5, and we want to calculate some kind of integral of g. So first things first, we know because t maps f onto g, it's possible to write g in terms of f, which would actually be nice because we know how the integral of f behaves somewhat, or some information about that. So if we can rewrite g in terms of f, then hopefully we can get some kind of integral expression in terms of f, which we know how to work with. Let's try to do that. What exactly is this transformation saying? We have a reflection in the y-axis, and then a dilation by a factor of 3 from the x-axis. If you want, you can go through this manually, writing out x prime equals negative x and y prime equals 3y plus 5 if you want to. Or you can just do it manually just by looking at it. And hopefully you know this method though. Otherwise, check the textbook or something. So how do we do that? Well, first of all, we're starting with f of x, and we're applying a reflection in the y-axis. So that means f of x gets turned into f of, well, negative x. We're replacing x with negative x. And then y prime turns into 3y plus 5. So we have a dilation from the y-axis, or from the x-axis rather, by a factor of 3. And then we translate up by 5. So we have a plus 5 here. Okay, so this is g, because that's what happens when you transform f, you get g. So what we can do is we can rewrite the integral there. So the integral we're interested in as the integral from negative 3 to 0 of 3 f of negative x and then plus 5 dx. Which is nice because now we've got an integral involving f. Let's split this up a little bit. So this is 3 integral from negative 3 to 0 f of negative x dx, and then plus 5 times the integral from negative 3 to 0 of dx. Okay, now let's rewrite that first integral. So 0 to 3 of f of negative x dx, and then plus, now what's exactly 5 times the integral from negative 3 to 0? Well, this is just going to be 15 because the length of the interval we're integrating over is precisely 3. Also, it has to be in the correct orientation as well. So we're going from small to big, negative 3 to 0. So it's the length is 3, and then times 5, that's going to be 15. Okay, now let's try to deal with this first integral over here. That's a little bit confusing, isn't it? Well, let's draw out a picture. We know, what do we know so far? We know what the integral of f, so if this is f over here, we know what the integral from 0 to 3 is. So let's pretend it's something like this. Here's the integral from 0 to 3. The area there is precisely 5. Now what we're trying to do is we're trying to integrate f of negative x. Now what is f of negative x? It's simply f, but you reflect in the y-axis. So imagine grabbing this curve up over here and just reflecting it in the y-axis, something like that. And we're trying to take this guy and integrate from negative 3 to 0, which looks something like this. Negative 3 to 0. Now, stare at this over here. Aren't these two areas the exact same thing? Because you're just reflecting the area. If you're reflecting the area, then the area is not changing. So this integral here, you can argue that that's just equal to 5 yet again. If you do spec, actually, you can do a nice substitution. You can do u equals negative x, I believe. For the spec kids, that's something you can try, and you'll still get 5. Okay, so that's going to be 15 plus 15, which is 30. So that's going to be option E. Alright, so that's it for the 2016 exam, multiple choice. interesting selection of questions. 19 and 20, those were pretty tough one. What else was tricky? Everything else was pretty standard, I believe. I mean, you just do have to pay attention to a few details with some of these questions, but all in all, it was quite a doable one. Most of these earlier questions anyways. Yeah, so that was a pretty alright exam in my opinion. Plenty of people would have done fairly well. Final few questions would have been a bit of a mix though. Okay, so that's all for today's video. Hopefully that helped. And yeah, I'll see everyone in the next video. Bye bye.